Let's work through this problem carefully. We are given a right triangle in which the vertical side, or the perpendicular, is 12 units long, and the other two sides are not given. The question asks us to find the perimeter. Now, before we start calculating, let's think about something important. The perimeter of any closed figure is simply the sum of all its sides. So, in this triangle, the perimeter would be the first side plus the second side plus the third side. However, only one side is given. The base is unknown, and the hypotenuse is also unknown. Since all side lengths are stated to be positive whole numbers, we are going to find every possible integer solution and then determine all possible perimeters. If you enjoy step-by-step geometry explanations like this, don't forget to like the video, subscribe to the channel, and leave a comment with your answer before we finish. Now, let's assign variables. Let the given vertical side be A, and since it is given as 12 units, we have A equals 12. Let the base be B, and let the hypotenuse be C. Because this is a right triangle, we can apply one of the most important results in geometry, the Pythagorean Theorem. The Pythagorean Theorem states that in any right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. Therefore, we can write c squared equals a squared plus b squared. Now let's substitute the value of a. Since a equals 12, we obtain c squared equals 12 squared plus b squared. 12 squared is 144, so this becomes c squared equals 144 plus b squared. Now let's move b squared to the left side. Doing that gives us c squared minus b squared equals 144. Let's look at this expression carefully. On the left side, we have c squared minus b squared. This matches a well-known algebraic identity. The identity says a squared minus b squared equals a minus b multiplied by a plus b. Applying that identity here, c squared minus b squared becomes the quantity c minus b multiplied by the quantity c plus b. Therefore, our equation becomes the quantity c minus b multiplied by the quantity c plus b equals 144. Now, this is where the interesting part begins. Since the product of these two expressions equals 144, we must find all factor pairs of 144. Because c and b are whole numbers, both expressions, c minus b and c plus b must also be whole numbers. Let us write the positive factor, pairs of 144. We have 1 multiplied by 144. We have 2 multiplied by 72. We have 3 multiplied by 48. We have 4 multiplied by 36. We have 6 multiplied by 24. We have 8 multiplied by 18. We have 9 multiplied by 16. We have 12 multiplied by 12. Now notice something important. Since c plus b is always larger than c minus b, we only need to consider factor pairs where the larger factor corresponds to c plus b, and the smaller factor corresponds to c minus b. Also, because c equals the sum of the two factors divided by 2, and b equals the difference of the two factors divided by 2, both factors must have the same parity. In other words, they must both be even or both be odd. Since 144 is an even number, we need pairs that are both even. Therefore, the valid factor pairs are 2 and 72, 4 and 36, 6 and 24, 8 and 18, and 12 and 12. Let's examine each case one at a time. First, suppose c minus b equals 2 and c plus b equals 72. Let's add the two equations. The negative b and positive b cancel each other, leaving 2c equals 74. Dividing both sides by 2 gives c equals 37. Now substitute c equals 37 into c plus b equals 72. We get 37 plus b equals 72. Subtracting 37 from both sides gives b equals 35. Therefore, one possible triangle is 12, 35, 37. Let's quickly verify. 12 squared is 144. 35 squared is 1,225. Adding them gives 1,369. 37 squared is also 1,369. So the triangle works perfectly. The perimeter in this case is 12 plus 35 plus 37, which equals 84. Now let's move to the second factor pair. Suppose c minus b equals 4 and c plus b equals 36. Adding these equations gives 2c equals 40. Therefore, c equals 20. Substituting into c plus b equals 36 gives 20 plus b equals 36. Therefore, b equals 16. So another triangle is 12, 16, 20. Checking quickly. 12 squared plus 16 squared equals 144 plus 256, which equals 400. 20 squared is also 400. So, this solution is correct. The perimeter becomes 12 plus 16 plus 20, which equals 48. Now let's continue. Suppose c minus b equals 6 and c plus b equals 24. Adding these equations gives 2c equals 30. Therefore, c equals 15. Substituting into c plus b equals 24 gives 15. Plus b equals 24. Therefore, b equals 9. So another triangle is 12, 9, 15. Verifying 12 squared plus 9 squared equals 144 plus 81, which equals 225. 15 squared is also 225, and therefore, this solution is valid. The perimeter is 12 plus 9 plus 15, which equals 36. If you're following along, pause for a moment and see if you can predict the next triangle before I calculate it. Also, if you're enjoying the explanation, don't forget to like and subscribe because it really helps the channel grow. Now, let's examine the next factor pair. Suppose c minus b equals 8 and c plus b equals 18. Adding these equations gives 2c equals 26. Dividing by 2 gives c equals 13. Substituting into c plus b equals 18 gives 13, plus b equals 18. Therefore, b equals 5. So another triangle is 12, 5, 13. Checking. 12 squared plus 5 squared equals 144 plus 25, which equals 169. 13 squared is also 169. Therefore, this solution is correct. The perimeter becomes 12 plus 5 plus 13, which equals 30. Finally, let us look at the factor pair 12 and 12. If c minus b equals 12 and c plus b equals 12, then adding gives 2c equals 24, so c equals 12. Substituting back gives 12 plus b equals 12, which means b equals 0. But a side length cannot be 0 because a triangle must have 3 positive sides. Therefore, this case is not a valid triangle and must be rejected. So, after checking all possible factor pairs, we find that there are exactly 4 valid right triangles with positive whole number side lengths and one side equal to 12. These are 12, 5, 13, 12, 9, 15, 12, 16, 20, and 12, 35, 37. Their corresponding perimeters are 30, 36, 48, and 84. Therefore, there is not one unique perimeter. The correct conclusion is that the problem has 4 possible answers, when all side lengths are required to be positive whole numbers. The possible perimeters are 30 units, 36 units, 48 units, and 84 units. Make sure to comment which perimeter you found first. Like the video if this method was helpful, and subscribe for more geometry and mathematics problem-solving videos.